Alright, now we're going to look at applications using the law of sines, right? Okay, so first we have a flagpole situated on a hill that makes an angle of 18 degrees with the horizontal. How tall is the flagpole if its shadow is cast 14 meters downhill when the angle of elevation of the sun is 31 degrees? Okay, so what is going on here? Well, first thing we need to do is we need to draw a picture. Alright, so how do we draw a picture? Well, we're going to start with the hill. So if I have horizontal, then this is going to be my hill. And I know that that makes an angle of elevation of 18 degrees. So I know this is 18. And then I have the sun. So that's this fireball in the sky. He's got a fang. And then I have a flagpole. So pole for the flag. And I know that this, so the angle of elevation of the sun is 31 degrees. So that means this entire angle is 31 degrees. So if that whole angle right there is 31 degrees, then I know this angle right here is going to be 13 degrees. So I'm going to say this angle is 13 degrees. Okay, and what else do I know here? How tall is the flagpole if its shadow is cast 14 meters downhill? So I'm going to say that this, let's use purple. So this right here, the purple, that is the shadow. So I know that that is 14. So we are trying to figure out how tall is the flagpole. X. Alright, so that's a picture. Get to it. Pause the video. Unpause when you're ready to check. Alright, so I end up with the flagpole is approximately 3.674 meters tall. How do I come up with that? Well, here's my work here. But I also added a little bit more to my picture. So if I extend the flagpole through the hill, then I create a right angle down here with the horizontal. So then I know that this angle here has to be 72 degrees because I have a right triangle. Then I know this angle here has to be 108 degrees because those are supplementary angles. And then I know that this angle right here has to be 59 degrees because I know all of the angles in a triangle add up to 180. So then I can do x over the sine of 13 equals 14 over the sine of 59. Boom. Law of sines. Solve for x, I get 3.674 meters, and then of course I always answer the problem in the context of the problem because that's just what I do, and because that's what we're supposed to do. Alright, next one. Angle of elevation to the top of a building is 21 degrees. At a point 80 feet closer, the angle of elevation to the top of the same building is 33 degrees. Approximate the height of the building. I do want to point out, we have done problems like this without the law of sines. So you can do this without the law of sines, or you can use the law of sines. It's up to you. It is a little bit quicker and easier to use the law of sines. First thing, draw your picture. So pause the video, try to solve the problem, but at least try to get the picture down. Unpause if you're confused, and I'll have a picture for you, and then I'll ask you to pause again. So pause, work. Alright, so here's the picture I came up with. Lovely building right here. Here's H, that's what we're trying to find. So from some point, I see the angle of elevation is 21 degrees, and then I move 80 feet closer, and now the angle of elevation is 33 degrees. Now I also found that this angle was 147 because that's a supplement. I'm going to call this X because I'm going to use that to solve, and then I know that this angle is 12 degrees because all angles in a triangle add up to 180. So if you didn't solve yet, now that I have a picture for you, try to solve for H. Pause the video again. Unpause when you are ready to check. Okay, so here we end up with the building is approximately 75.102 feet tall. How do I come up with that? Well, I used the law of sines to find x. So I said x over the sine of 147 equals 80 over the sine of 12. And then I solved for x, and I got x is 209.566 feet. Now from here, I didn't use the law of sines anymore. You can, but you don't have to. I know that this is a right angle because I'm assuming that the building is perpendicular to the ground, which I know you're not supposed to assume things, but that's what I did. So then I just used right triangle trig, aka SOHCAHTOA, aka what we do, and I did sine of 21 equals h over 209.566 because all I'm doing is sine of an angle equals the opposite over the hypotenuse. Again, you could use law of sines here though by doing the sine of 90, but you don't need to. So then I get h is 75.102 feet. Moving on. Oh, how'd that get in there? Hey, Trev. Alright, so here we have a beautiful love story. Two people are walking toward each other in a path through the park. The path runs east and west. A hot air balloon is directly above the path between them. One of the walkers, a female, sees the balloon when looking east at an angle of elevation of 46 degrees. The other walker, a male, sees the balloon looking west at an angle of elevation of 72 degrees. The walkers are 55 yards apart. How far is the balloon from the male observer? That's beautiful, isn't it? Alright, draw a picture, solve the problem. Pause the video. Unpause, we're ready to check. Alright, so I came up with the balloon is 44.809 yards from the male observer. How did I come up with that? Well, oops, sorry, I think I got messed up. So I drew a picture. So I have the male and I have the female, and I know that the female saw the balloon when she was looking east and the male saw the balloon when he was looking west. So the male has to be east of the female and the female has to be west of the male. They are 55 yards apart. Little f right here is actually the distance from the male to the balloon. There's the balloon, awesome. I know this is an angle of elevation of 46 degrees. The male's angle of elevation was 72 degrees, therefore this has to be 62 degrees. So I know little f over the sine of 46 equals 55 over the sine of 62, so little f equals 44.809 yards. There we go. Law of sines. It's beautiful.